So today we're going to be adding or subtracting rational expressions. The big thing here is that you have to have the denominators the same in order to add them together. And how we do that is to multiply by a special form of 1. Since any number over itself is the same as 1, it does not change the value of your expression. And so that's what we're going to take advantage of when we do this. So our rules here: factor everything just like we've been doing. Compare the denominators. If they are the exact same, you can skip to step 3, which is add or subtract the numerator and then place over the common denominator. The thing to remember is that the denominator does not change its value when you add, only the numerator. Okay? If they're not the same, then we have to do and multiply by our special 1 to get the denominators the same so that we can add the numerators. Okay? And the fourth one, reduce if necessary. That rarely happens, especially if you look to reduce first after factoring, then you should be fine. But let's look at our examples. So first, we look and see, do we have to factor anything? Well, 9 doesn't factor. Well, you could have 3 times 3, but it's not going to help us in this problem. We have x plus 1, we have 2x. So these aren't factorable. So let's go and look at the denominators first. And looking at the denominators, they are the exact same. So therefore, x plus 1 is going to be the denominator of our answer. And so now you look at the numerators. We've got 9 minus 2x, which gives us our answer of 9 minus 2x over x plus 1. Look at number 2. Okay, we look at the denominators here, and I see that they both have an x, but the numbers are different. So therefore, what we have to do is do our multiply by our special value of 1. Since the first fraction has a denominator of 5x, it does not have a 6 in it. So therefore, we have to multiply it by 6. And since we're multiplying on the bottom, we also have to multiply the top by 6. Likewise, on the right side, you have 6x, but you don't have a 5 with it. So therefore, we're going to multiply that by 5. And again, we're going to multiply by that special form of 1, 5 over 5. So now we go through. 6 times 12 is 72. 6 times 5x is going to be 30x. Minus 7 times 5 is 35. Over 6x times 5, which is 30x. So now we have denominators the same, so our answer is going to be over 30x. And if you look at the numerator, you got 72 minus 35, and 72 minus 35 is 37. Okay, 37 is a prime number, so it can't reduce with 30, even though you feel like it should. It cannot. Okay. All right, so number 3, I'm going to break this down a little bit. 3x squared is really 3xx plus 5 over 4x. So if we look at these denominators, they both have 1x in them. Okay? So now if we analyze, we go, all right, first fraction, we have 3x on the bottom, we have 4. Well, we don't have a 4, so that means we must multiply it by 4. All right, and you have to do it top and bottom, special 1. Then on the right side, you've got a 4, but you don't have the 3x, so that means you have to multiply by 3x over 3x. 3x top, 3x on the bottom. So now you get 4 times 8, which is 32. 4 times 3 is 12, x times x is x squared, plus 5 times 3x is 15x, over 4x times 3x, 12x squared. you look again. Denominators are the same. So this is going to be over 12x squared. Then you look at the numerator. You got 32 plus 15x. Well, that's 32 plus 15x, but I like to put the x term first, put it in standard form. And there you go. Done. Okay? Now they start to get a little bit more complicated. Instead of numbers and variables, or they're the same on the bottom, they are now different, but you have two expressions. Okay? So the big thing here is to make sure there's parentheses around those so you know that you either cancel the whole thing or nothing. Alright, so now, as you can see in the first fraction, we have an x plus 4, but we don't have an x plus 6. So that means we have to multiply top and bottom by x plus 6. Excuse me. Alright, now as you can see in the first fraction, we have an x plus 4, but we don't have that in the second fraction, so we have to multiply by x plus 4, top and bottom. So here's what we get. Distribute the 3, and you get 3x plus 18 over x plus 6, x plus 4. Don't worry about multiplying the denominator out. Okay? Just multiply the numerators. We'll leave the denominators factored. Okay? Now you got 1 times x plus 4, giving you x plus 4. And that'll be over x plus 6 times x plus 4. Now, look. Our denominators are exactly the same. So our answer is going to be over x plus 6 times x plus 4. Now, if you look at the top, the numerator, we got 3x plus 18 minus x plus 4. So you go through 3x minus x is 2x, and then 18 minus 4 is 14. And that's your answer. Alright, so moving on to 5, look at the denominator. The first fraction has an x minus 3, but doesn't have an x plus 1, so that's what we have to multiply, top and bottom. Then the second one, you have an x plus 1 on the bottom, but you don't have an x minus 3. So you're going to multiply top and bottom by x minus 3. So now, distribute the 9, and you get 9x plus 9 over x plus 1 times x minus 3, plus, distribute the 2x, you get 2x squared minus 6x all over x plus 1, x minus 3. Now, again, we look at the denominators. They are exactly the same. So our answer is going to be over x plus 1 times x minus 3. And if you look at the numerators, we got 9x plus 9 plus 2x squared minus 6. So going from here, we have a positive 2x squared. Then you have 9x plus a negative 6x will get you a positive 3x. And then the 9 comes in at the end. And we're done. Alright, you try to factor 2x squared plus 3x plus 9, but I think you'll find that it's not going to work for you. Okay? Now on to the last one. Okay, you look at it, we only have one x value. So that means everything. Okay, if you look, sorry about that. This is x over 1, this is 2 over 1. These last two terms are missing an x, so we have to do times x, times x, times x, times x. And so what we get is x plus 3 over x plus x squared over x plus 2x over x. Now, if you look, all three denominators are exactly the same, so our answer is going to be over x. And then you take your numerators, and it looks like each time you're adding. So we have an x squared. X plus 2x is 3x, and you have the plus 3 that doesn't change. And there's your answer, x squared plus 3x plus 3 all over x. Alright, and the next notes will be solving rational equations.